Hello students, how are you all? Hopefully all are good. And today the class which we are starting, that is the class of our second unit current electricity. The topic we are continuing with respect to our previous class, and the today's topic is specific resistance. In the previous class, we have discussed about the concept of Ohm's law. After that, we have discussed the concept of resistance along with its cause. And over there, we have studied this, that resistance is the property of a conductor of a medium like this wire, through which we have to pass electric current. For that, we have to bring all its charge carriers in the form of free electrons in a definite direction, but whenever they start moving in a definite direction, they get collided with the positive ions in between their path, and that causes hindrance in their motion. This property is termed as resistance of the conductor, or here the cause of this property is because of collision of these free electrons with the positive ions. This we have discussed in the previous class. And now today we are going to discuss about its detailed concept, which is known as specific resistance, and also we call this as resistivity. This concept helps us in understanding the basic concept of resistance again, where we are going to discuss the property of resistance specifically for a material, and that's why we call it as specific resistance. To understand this, we have to consider a theory where we will study about the effect on resistance due to configuration of the conductor. Suppose we have a conductor of certain length, suppose L, capital L, and cross section area capital A. So this conductor will be having certain value of resistance. It will provide certain hindrance for the passage of electrons or electric current through it. So that will be called the resistance of this conductor. That resistance, how it will affect along with this length and cross section area, this we will assume here. So after performing any suitable experiment, experimentally we found, it is found that the effect of resistance, the effect of these factors on resistance, cross section area and length, how will it impact? According to the concept, this we all know easily, that these positive ions will cause collision of electron, and with the collision, electron will pass through the conductor to make electric current in a particular direction through the conductor. Now these collisions causes opposition to the flow of electron or opposition to the flow of this electric current through the conductor, that causes resistance. Now what we are assuming here, we are considering, suppose we have a conductor in which we are increasing the length. Suppose for given length L, we have shown 3 collision in this conductor. If we are increasing the length of the conductor, definitely the number of collision will increase, and if number of collision increases, then what will be the effect on the value of resistance, the hindrance, the opposition? Definitely it will increase. So if we are increasing the length of the conductor, then more number of collision will take place and it will cause more resistance. So experimental observation states that resistance of conductor R, we are assuming it as R, this R is directly proportional to L, where L is what? It is length of conductor. Greater the length of the conductor, greater will be its resistance, because it is the characteristic property of the conductor. Another thing, if we are assuming a conductor of increased cross section area, suppose we are increasing the cross sectional area, then again the number of positive ions will increase, but certainly it will provide certain space comparatively easier than the current one. If here we are assuming a conductor of another conductor of same length but greater cross section area, the number of collision, or we can say rate of collision, will certainly decrease, and therefore that will cause the decrease in resistance on increasing cross section area. So another relationship we have, R is inversely proportional to cross section area. Here A means cross section area of conductor. This we can understand in another way also. Over there we have related the concept of resistance through the motion of a vehicle over a traffic road. So if we have a road having traffic on a certain patch, there will be problem in passing through that. Just like that, electron is facing problem through the conductor to produce electric current when it is passing. Now if that patch increases, means if at longer length the traffic jam is there, then will be having more problem. We will be having more problem, so more resistance will be there. But at the same time, if we are having wide road with certain number of vehicles over there, comparatively we will feel easier to move through that way. So in the same way, if cross section area increases, then resistance decreases, and if length increases, then resistance increases. This is the relation which we have found through the experimental observation. Now from this theory, we can have two different conductors having same length and same cross section area should have same resistance, but experimental observation again says that another certain factor is there which will impact the value of resistance, and the two different conductors will have different resistance, and these two different resistance is because of the certain specific nature of the material, and that specific material produces specific resistance, also known as resistivity. Here what we are doing, we are assuming the resistance depending on length as well as on cross sectional area, but when two different materials having different nature, one is made of iron, another made of copper, but of same length and same cross section area, when experimentally we counted their resistance, it is observed that they have different value of resistance. So this indicates that area and length also affects the resistance of a particular material, but along with that its nature also imparts some character towards the resistance, and that can be obtained by combining the relation R proportional to L by A, and breaking this proportionality we get equal to, and a constant term here that is denoted by rho, and this rho is used for the term specific resistance or resistivity. So here we can say that this factor rho is called resistivity, also known as specific resistance of the conductor. Now the requirement to define this term resistivity or specific resistance, we will use the same formula to define it. Definition can be given in this way, that relation of R is rho L by A. If we assume L as 1 meter and area as 1 meter square, then rho will be equivalent to R. And this is the way how we can define the concept of specific resistance or resistivity, that specific resistance or resistivity is the resistance of a particular conductor of this configuration where it has 1 meter length or unit length and 1 meter square cross section area, or we can say unit cross sectional area. So to define this we can say, hence specific resistance is the resistance of a conductor having unit length and unit cross sectional area. Unit length and unit cross sectional area. Then SI unit if required to give, then again we will use the same formula, R equals to rho L upon A. After cross multiplication we will get rho is equals to RA upon L, and from that ohm, area is meter square and length is meter, so it will be ohm meter. If we need to give its dimensional formula, so for resistance, that is ohm, we have already written ml2 t minus 3 a minus 2 into meter is L, so L and L will be ml3 t minus 3 a minus 2. This would be the dimensional formula for the vector. And importantly, the formula for specific resistance rho, r into a divided by l after this cross multiplication, this is not the exact form of specific resistance. What is the exactly formula for this term we have, that we will discuss after this. So till the time you can note down the remaining part. So now the very important relation which will tell us how the value of resistance is affected on length and area, and how resistivity is not affected by the two terms. So for that we have to take it in the form of note, and here we will consider the concept first. The resistance, as we have already discussed, as m upon n, ml upon n square tau a. Also the value of r can be written as rho l upon a, and from this relationship, if we compare the two, in place of resistivity we have this term m upon n square tau. So this will give the exact form of resistivity m upon n square tau, which clearly indicates that no dependency on length and cross section area is there in the relationship. So from this relationship we can say that the resistivity is independent of length and area. Someone can say that rho is equals to r into a upon l. So from that relation a and l should impact the value of rho, but it is just the cross multiplication relationship which we are getting after cross multiplication. It is not exactly the dependency relationship, because if we write the relation rho is equals to ra by l, so we know that the value of l and a will impact on r, and in such a way that if a is doubled, r will be halved. So 2 and 2 will be cancelled. If length is doubled, r will be doubled, 2 and 2 will be cancelled. Or if l is tripled, r will be tripled, 3 and 3 will be cancelled. Value of rho will remain independent. So this is the actual formula of resistivity, which helps us to find the dependency on what factors it is depending. So m is constant term, E is constant term, n is the number density of electrons, free electrons. So that depends on the specific nature of the material, and hence rho is the factor for specific nature. Along with that, it is depending on tau, relaxation time also, which depends on temperature. So temperature may affect the value of resistivity, nature of the material may affect the value of resistivity, but length and area cannot affect the value of resistivity, but they affect the value of resistance. So this is very important, that R depends on L and A, but rho is independent. This is very important relation, independent on or of factors length and cross sectional area. So if we need to write on what factors it is depending, so we can write that in this way, that formula for resistivity is m upon n e square tau. So here rho is inversely proportional to n and rho is inversely proportional to tau. So from here we can say number density of electrons, and another is relaxation time over which it is depending. So nature of the material will impact the value of n. So nature of material will change the value of resistivity. Temperature can also affect the value of relaxation time, and hence can affect the value of resistivity, but there is no impact of length and cross sectional area on this factor. So if anytime anyone is asking about if length is doubled by stretching or compressing, then how the value of resistivity changes, so your answer must be it will not change, it will remain same, it will remain fixed. So resistivity factor denoted by rho is independent of the factor length and cross section area. Actually it is the basic factor which makes the resistance of the conductor for the given length and cross sectional area. Okay, so you can note down this. So this is the time to discuss a question based on the concept which we have studied now, and that is this question we will discuss here. According to question, given conditions are a wire of resistance 3 ohm is stretched to twice its original length. Find new resistance of the conductor, and also we have to express the concept how will resistivity of the conductor is affected. So first of all, if we start the solution, I will again suggest you just try this question on your own, and if you are not able to do that, definitely you must have learned something, because if you have tried the question, it means you have at least 50%, 60% question you have understood it. So if you have solved it, and let's check whether your method is correct or not, or answer also. So according to question, the given resistance, initial resistance we can say R1, it is given as 3 ohm, and it is said that wire is stretched to twice its original length, so L2 must be twice of L1. They are asking about new resistance R2 and also about resistivity, and that we have already discussed that on stretching or compressing means due to change in configuration, length and cross section area, no change on resistivity is there. So we can draw a diagram for this resistance R1 for length L1 and cross section area A1. Now this wire is stretched, and it is stretched in such a way that its length becomes double. So L2 is twice of L1. So A2 will also change. How much it is changed? We don't have any value. And now we have to find the value of resistance R2. Here the factor which will remain unchanged, that is the resistivity of the conductor. Along with that, volume initial and volume final of the conductor will also be same. Initial volume and final volume must be same, because this is the case where wire is stretched to double its length, no material is removed, no material is added, just there is reformation of the wire with same material. So volume of the conductor must remain same, and that will help us how much value this area of cross section is changed, because this area is also affecting the value of resistance along with length. So we should have the effect of both the factors, and for that first of all we will consider as volume initial and volume final are same. So cylindrical shape is there, so initial and final volume must be A1 L1 as well as A2 L2. So A1 is as usual, L1 is as usual, A2 is as usual, but L2 is twice of L1. So L1 and L1 can be cancelled, and from here A2 is equals to A1 by 2. So using this concept we can have the initial and final resistance. So as initial resistance can be written as initial resistance, which is R1, this must be rho L1 upon A1. Rho is only rho, not rho 1, because it will remain same. So this is equation number 1 we can write. And final resistance, this must be R2, which is rho L2 by A2. And now we can put the values also. A2 is A1 by 2 and L2 is twice of L1. Here only in the relation, L2 is twice of L1, A2 is A1 by 2. 2 in numerator will become 2 into 2 4, and the expression will be 4 into rho L1 by A1. The expression in the bracket, rho L1 by A1 is R1, so 4 R1, and this means 4 into 3, 12 ohm is the final answer. Also resistivity remains same, no change in resistivity, as material is not changing nor there is change any temperature also. So the factor resistivity will remain same, but the resistance will be affected and it will become 12 ohm resistance. Okay, hopefully you have understood this. So you can note it down by pausing it. As we know that the language is very important, especially in numericals, so we have to take care of the keywords also. In relation to that, the question which we have already discussed, This can be changed easily by changing a simple word here. From in place of to, I am writing by, and now it is a new question because of change in only a one word. So a wire of resistance 3 ohm is stretched by twice its original length. Find the new resistance of the conductor and how will the resistivity will affect. Obviously resistivity will remain same, but the answer will not be as same as we have discussed earlier, that is 12 ohm. It will be changed because now the factor by is telling something different information. If it is written like this, a wire of resistance 3 ohm is stretched to twice its original length, it means with respect to initial, the final total length is twice. But here is stretched by twice its original length, then the new length will be L plus twice of original, that means 3L. So here L2 will be 3L1. So similarly A2 you will get as A1 by 3. This is the very simple concept that whatever the factor is there in multiplication with length, it will be in division with area. If any factor is there in division with length, it will be in multiplication with area, vice versa. So directly you can use, or you can use initial and final volume equal to each other as we have discussed in earlier, and then you can find the method. Using the method you can find the answer. So the answer for this question you will do by yourself, and here it must be, answer should be 27 ohm. So you can try it on your own, and let me know whether you have solved this or not by commenting in the comment section. So you can note down this question also. So this was the concept related to resistance, and with this we have completed the concept of complete resistance associated with a conductor. Some questions we have already discussed. One question is given for you as homework. Hopefully you will do that. And for today's class we are completing this here. In the next class we will discuss further concepts related to these factors, and we will meet in the next class then. Till then, take care. Goodbye.